Sometimes you'll get a 2D CAD drawing that has a representation of a part that has to have some bevels cut in it, like this part here. So normally you get some top geometry, and you'll probably get a side view. This would be the top of the side view, and this would be the bottom. So what I've done is I've gone and drawn this based off of what we have here. And so basically we have these that are going to be cut at this angle, as well as this hole that's at this angle through the material. And this is 2.5 inch thick, and we'll presume that it's foam, so a typical water only application. So what I'll do first is copy these over and then start moving things around here. So I'll use my copy command just on my CAD tab, or I can do Shift C for copy, and I'll just place these over here somewhere. And this part here needs to be mirrored, so I'll use my mirror command, which is under my transform menu. I've actually moved it up to here, but normally it's under your transform submenu, or you can do Shift M, and I'll select this and then hit enter, and first point of mirror line I'll click here, and since I have my ortho button on, I can just drag my mouse over to the right and it'll mirror it along that line there. And I'm not going to keep the original since I already have the original over there. And then what I'll do is I'll move this on top of the other portion of the drawing there. So right now this is all separate lines. To make things a little bit easier to move around, you can use the join command and join all those outside lines together, so you only have to click on one thing to join it all together. So I'll do join, drag a box around here, and hit enter, and then down at the bottom it prompts you for tolerance, and right now it's defaulting to 0. I'll just hit enter for that. So now if I click on any one of these outside lines, it gets the entire outside, and then also click here to pick the circle. And then I'm going to move this, so I'll just use M for move from this endpoint here down to this endpoint here. And then usually what I like to do is change colors at the top and bottom, just make it a little bit easier to distinguish, so I can select the bottom geometry. Could have done this before the move. So now we're ready to take this into the 3D area here. So on our CAM tab, just check to see if we have 2.5 inch thick material in my material database, which I don't, so I'll go ahead and make a new material thickness. So I'll click on edit material, and then I'll add 2.5, and OK. Alright, now in the 3D 5x area, we've got the choice of 3D 5x or ruled. If you choose the ruled, you'll choose top and bottom geometries, and then it'll make surfaces out of those, which we'll then use when it does its collision checking. So first it wants to know what the top geometries are. So I basically hover my mouse so my top geometry is highlighted red, and I'll left click. And then I also want this circle here, so I make sure that's highlighted red, and I left click. And I'm done picking my top geometries, so I hit enter, and then it wants to know what the bottom geometries are. So we'll hover near this, and when that's blue I left click, and then I also want this circle here, so when that's blue I left click, and then I'm done selecting bottom geometries, so I hit enter. So now this brings us into the 3D world here. So I can use things like my measure command and verify that these two surfaces are 2.5 inches apart, which they are, so that's good. So what we need to do is go ahead and add our toolpath. iGems has already picked out the edges based on the two geometries that we pulled in there, top and bottom. So on our CAM tab, I usually like to set my 0 point first, so I'm going to go ahead and click on the 0 point, and I'm going to set my 0 point at the lower right hand corner at the top of the part. And then I'll go ahead and add a toolpath. So we're going to use the ruled method to connect top and bottom. We'll do fix Z since it's a flat surface that we're cutting. engagement upper to lower, which isn't really going to matter for water only since I'm going to cut this at a fixed rate anyways. I'll set my piercing to user. Tilted piercing will be fine. Quality can just set that to medium. We're not going to need any overcut typically for water only. So we'll click on the plus button here and we'll start with the circle. Click on the top of the circle where we want to pierce, go all the way around, hit enter, and then the direction that we want to go around, just left click, and then your lower curve down here. And then we'll add our lead in and lead out. So I wait for that line to lock in there at the 9 o'clock position, hit enter, and then we've got a little bit of a lead out, which if it were water only, probably don't need that. Can get rid of that. Now oftentimes what will happen when you're taking in your geometries in this method is that iGems might get a little bit confused as far as the top and bottom connections here. So if we try to run a simulation on this, let's change to our water only head here. See that movement that it made in there. So what we can do is, rather than using a ruled on this, we can switch this to fixed. And then right now it's fixed, just going straight through vertically. Click on the little edit button here, and if we knew the angle, we could specify that. We'll do 2 points, and I can do either do C for center and do center of here to center of here. That'll pick up that angle. So you can see it's 27.74 degrees, and if we do our simulation now, should look a bit smoother. That looks better. And so now we'll add our toolpath to the outside. So go back to plus button, add the cut. So upper curve here, and we'll pierce here. We're going to go all the way around, so we hit enter, and we'll go in this direction, and then this is our lower curve, and then lead in and a little bit of lead out, or not, or a little bit of lead out. Okay, so now again in these corners here, iGems is going to get a little bit confused, but we'll straighten it out by adding some connections through these corners here. So I can click on the edit button here and click on the little plus button down here to add connections, and I'll just basically, each of these corners here, we'll add some connections, and the more connections you add, usually the better the result is going to be. So you can see already that things are getting a little bit better as it works through there. So let's just see if that's all I need. I'll click on done here, and I'll go ahead and click on simulate. And we'll see if we have any extraneous head motion as it's going through the through that area there. Did you see it wobbling as it's going through there? So we'll add some more connections and smooth that out. And when it did its initial pierce, it was at a strange angle there. You can see some of those lines that's got connecting there, so we'll just add connections onto there, and we'll just go through and add connections onto each of these corners. So if we had had a 3D model to work off of, this would have been a lot easier, but if you don't have the model, then this is the way to do it. here down to here. And we'll add one back here, and probably add one on the corner back here. Okay, I think we've got them all, so we'll go ahead, click on Done, and we'll do our preview. Spin this around from the other side here. So you can see now it goes to that 27.74, and it's going to stay like that throughout this notch here and along this entire edge. So we don't see any change in that 27.74, which will give us nice cut quality along there. And then as it comes out of this last corner here, it starts to straighten up until it's vertical there at that corner, and then it should stay at 0 degrees throughout the rest of the part. Okay. And we can close this. We can adjust our rapid height. Click on the rapids button. We've got 1/2 inch between cuts. Click on distance to accept that. Click on OK. And we've already set our 0 point on the part. And so now we can just go ahead and create it. And we'll just change our part name. We'll just go with the part. We'll just go with the next number in the sequence here. Down at the bottom is going to prompt you to select surfaces. I'm just going to do Control A to select all, and then Done. And there's our part. So then we can set our 0 point, and always remember to click on the part button. Z matches our material thickness 2.5, so that's good. So now we can click on the CNC button and do our preview. And then I'll just do a quick review of nesting a 3D 5-axis part. So we'll go back to here, go to our Nest tab, click on Auto. Down at the bottom, prompts for parts. So we select that, hit Enter. Select Sheets and Obstacles. Right now I don't have any sheets on the screen to choose from, so I'll just hit Enter. And part quantity, I'll just put in 100. And sheets, I'll pick out a sheet of, we'll do 48 by 96. And we've got our collar width, which we can adjust if we need to, how many sheets that we want. We'll just go with 1 for right now. So we got our spacing between our parts, which we'll leave that where it is. And then we'll go ahead and click on Nest. And that's probably about as good as that's going to get. So we'll click on Stop, and then OK, and Close. And then we'll go ahead and go back to our Cam tab and set our 0 point on the sheet. And then this is always a thing to remember with parts that come from the 3D 5-axis world. is we want this Z to be equal to our material thickness. When we're doing the single part, I showed you just to click on the part and the Z goes to that 2.5, but in this case when you do that on a nest, it also moves it to the corner of the first part where we had the 0, point set, which we don't want that. We'd want that more at the corner of the sheet. So what you can do is go back to where it was, use this pick button and pick the corner of the sheet where you want to start, and then click on this 2D 3D button here and then type in your material thickness, and then that way your Z heights will be correct. So if you have any questions on that, let us know. Thanks.